So now we're moving on to section 5.6, which is all about the quadratic and complex roots. Here's the deal. We've talked about the quadratic equation. If we have a quadratic equation that's something of the form ax squared plus bx plus c equals 0, we can solve it by using this equation. X is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. That should be memorized, okay? Memorized. It's that important. I remember the bishop said it at a mass. He still knew it. He's getting pretty old. Anyways, make sure you know it. Well, what's going to happen now is now we're going to say, hey, we're going to use it where we have complex numbers in it, or where we have not real answers. Okay. Here's the deal. The stuff under the radical is going to be negative. That's what we're going to deal with. We didn't do that before. Remember when the discriminant was not less than 0? Well, now we're going to have those. All right? So the only difference is now we can take it a step further from previous problems. You can actually find the complex roots. Now, if we look at a picture of a graph, will they display the roots accurately? And the answer is, guess what? No. And that's because they don't cross anywhere. You can't see them. It doesn't cross in the real axis. They're complex. So you're going to see something. The graph will not touch that real axis. Okay, let's go right into the heart of it. Remember, when we solve this, we need A, B's, and C's. You can do a little manipulation to make it easier. So let's solve the first one. So before we can do anything, I suggest two things. Number one, you got fractions, clean them up. Multiply through to get rid of them. So in this case, I'm going to multiply everything by 2. So I'm really looking at 2x squared equals 2x minus 10. Oh, sorry, no. 2 times this is actually just x squared. And now, we have to get it equal to 0. Again, I like to make the a term positive. So x squared minus 2x plus 10 equals 0 is what we're actually trying to solve. So to do this, we look at the number in front. Here, it's 1. That's going to be our a term. Our b term is that number here. And our c term is our number there, which is 10. So now, all I got to do is plug it into my formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. So, b was negative 2, so it's negative 2 plus minus the square root, negative 2 squared minus 4 times uno times 10 all over 2 times 1. Now, if you ever see, write your answers in a plus bi form, that's usually a giveaway that it's going to be complex. Okay? This stuff under the radical, the discriminant, probably is a negative number. So we clean it up. 2 plus minus the square root of negative 2 squared is 4. And negative times the positive is a negative. 4 times 1 times 10 is 40 all over 2. Which if we clean this up, it's 2 plus minus the square root of negative 36 all over 2. Our discriminant is negative 36, which we said means it's imaginary. So now we got to look at the complex version of it. So now, all we got to say is, well, the square root of negative 36, isn't that, well, square root of 36 times the square root of negative 1, which is going to be 6i. So it's 2 plus minus 6i all over 2. And that is not an a plus bi form. Oh, plus minus. So again, you can split it up if you need to. 2 over 2 plus minus 6i over 2, which now cleans up to be 1 plus minus 3i. Right? That I would buy, our two answers are 1 plus 3i and 1 minus 3i. Now, if you look at those answers, what do you notice there? They are conjugates. Guess what? That always happens. Complex roots come in pairs, and they always come in complex pairs. So you're going to see that all the time. You're going to have complex roots that'll come in pairs. All right, so we got a bunch of practice, so let's see how we do. We'll practice until I run out of time. We've got 12 minutes. Videos are 12 minutes. So this is in our nice form. Don't have to do any work. So negative b plus minus the square root of b squared minus 4ac all over 2a. Let's do our a, b, and c. A is the number in front there, it's 1. B is negative 8. And c is 17. Is a 17. Lucky me. Negative 8 plus minus the square root. Negative 8 squared minus 4 times 1 times 17. Ugh. All over 2 times 1. Negative 8, well, that's positive 8. Plus minus the square root. 8 squared is 64. Negative, oh, that's negative. Alrighty, let's do this. 4 times 17. How about 2 times 17? That's 34. Well, I got two of those, so that's 68. And that's all over 2. Cleaning that up, that is 8 plus minus the square root of negative 4. Negative 4. No i's yet. Negative 4. All over 2. Now we can put our I in there. Square root of negative 4 is 2i. 8 plus minus 2i all over 2. And then as you can see, we can divide all of these by 2, which my final answer will be 4 plus minus 2i. That's what x equals. So you can write it, make sure you get the plus minus or else you're wrong. Makes it real easy. Now, I'm showing you these problems. The second one over here, I'm not going to do it by quadratic, but it should make sense. So when we do this problem, what would I do first? I'm going to multiply it by 5 just to clean this up. I don't like fractions as much as they're my friends, not when it comes to quadratic formula. Never put a fraction in the quadratic formula. Don't have to ever. Always change it to make it whole numbers. So those cancel, and I get x squared plus 25 equals 0. Now I could go through my quadratic process, but because there's no b term, couldn't I do this? Subtract it over, and then take the square root. What do people run into a problem with? Well, they know this is 5i. And that's what they write as their final answer. And I'll be like, wrong. Remember, I took a square root, you owe me, plus and minus. Remember, you're always going to get 2. Alright, let's look at this one right here. Again, no fractions. Do not deal with them. Multiply everything by 4. Those cancel out. I get x squared plus 21 equals 4 minus 8x. Alright, got to get everything over to one side. I'm going to move it to the left. Everything in the closet to the left. So, x squared, add 8x to that side, plus 8x, subtract 4, and you get 17. Okay. If you look, looks pretty familiar, doesn't it? It's going to be just slightly different. It's going to be negative 8 plus minus the square root of 8 squared minus 4 times 1 times 17. And didn't we just do this all over 2 times 1? Well, that's negative 8. And this is all the same over here. It's really just plus minus 2i all over 2. The only difference is that negative sign between the problem, which is negative 4 plus minus i. Oh my goodness, back here, I didn't even divide those. Make sure you divide both of them. 8 divided by 2 is 4, and 2 divided by 2. So this is wrong. This is going to be 8. Write it again. 4 plus minus I. Make sure you don't make that Monday mistake. Those are killer 2 points. You got to divide everything by 2. That's why isn't it easier to write it like this? And you see it. Alright, let's do the next 2. This one should be pretty easy because there's no b term. We can do this again. Take the square root of both sides. X equals, well, square root of negative 12. Well, isn't this 4 times 3? And then negative 1. So isn't this square root of 4 is 2. Square root of negative 1 is I. And then the square root of 3. What do we remember, though? Plus minus. And that's it. We could do the quadratic, but it's going to be a little longer. So the last thing we have is a wonderful little piece where we have next to the bottom. Remember, how do we do fractional equations? Clear the denominator. What's the LCD? 3x. So multiply everything by 3x. And then you'll notice the 3's go away, and then the x's go away. They have 25x squared plus 9 equals 0. Oh, look at that. No B term. I was nice to these. So if you look, you get 25 x squared equals negative 9 by subtracting 9. Divide by 25. Oh, x squared equals negative 9 over 25. You're going to take the square root of both sides. That is 3/5, isn't it? But, because it was negative, it was an I. And what do we always remember? Plus minus. So you can see that's some good practice there. I do have one more. Let's go with that. I would cross multiply this to make it easier. Get rid of it. And you get 17x minus 34 equals x squared plus 27x. Then move everything over to one side. I'm moving it to the right. 0 equals x squared minus 17x. So minus 17x, you get plus 10x plus 34. Using my quadratic, negative b plus minus square root of b squared minus 4ac over 2a. This right here is my b, so negative 10 plus minus the square root of 10 squared minus 4 times 1 times 34 over 2 times 1. Cleaning it up, right here, negative 10 plus minus the square root of 100, 34, 68 times 2, 6, 136. So what do you know? Minus 136 over 2, which is negative 10 plus minus the square root of negative 36 all over 2. As I'm running out of time, the square root of negative 36, 6i, negative 10 plus minus 6i over 2. Divide them out by 2, you get negative 5 plus minus 3i. And there you have it. You can see, just practice.